Hi all, my name is Vladimir. It's midnight in Moscow time zone, and you are watching the Nightly Code channel. As you remember, in previous stream, we have added controls for routing, routing mono channels of the device. And the unsolved problem was that the routing for SPDIF and loopback controls was reset. I didn't find any explanation to this at that time, but now I know the reason and I'll just explain what happened. So, let's look here and let me explain the problem. The problem was that when I have properly configured the device, and disconnected it from the original Focusrite software, I have just found that connecting the device to Linux will reset the settings of SPDIF and loopback outputs. I just compiled the kernel driver again, added additional debug information, and watched the logs of the dmask. And after doing some repeated test cases, I found that someone is resetting these settings manually. So that's not the problem of the driver. That's a real problem of the something that influences the process of the driver initialization. So in fact, we have correct initialization of the driver, but the state of the controls is unexpectedly reset. So I started to dig inside, and first of all, I have disabled the Pulse Audio server in my virtual machine. That didn't solve the problem, and I was required to find out more what's happening. And finally, I found the reason. And the reason was pretty easy. But I couldn't expect that that was it. So, in fact, we have a special directory in the Linux source in the Linux tree, which is located at the following path: var lib alsa, and there is additional file which is called the asound state. This file is read by the ALSA driver when the device is connected, and the configuration stored inside this file is applied to the device. I don't know who has created this file, but I suppose it was the Pulse Audio driver. This file was created, and as you see, this configuration is for the internal device emulated by the virtual box. And there was one more configuration for my Focusrite device. So when I removed this setting, the driver became working properly. So we can check it now that the driver works correct. So let's do some routing. I think I need to move the console to the main working screen. So Here's our device already connected to the virtual machine, and we will assign some routing. So there is no connection at this moment. Oh, there is it. Okay. So we will connect monitor output to analog 1 input. Can we do this? Yes. Then the analog 2 and so on. Then analog 3. Then analog 4 and so on. Here already was the assignment, but we will change it. Here the SPDIF connection will just route to SPDIF. And look back, we will route to, I believe, to ADED 1 and the ADED 2. Hi, Leon. Okay. Let's disconnect the device and look into the driver. So I'll just disconnect the device, launch the dmask -w, and I'll leave the file heading, and I'll just connect the device to the virtual machine. So here it is. Here we see that the driver is initializing, and we see that there is many debug output that I have already added, but we don't see any additional control reset. So we see that the routing is properly assigned here, and now we can go to the also mixture and look what's happening there. So we have additional dedicated console, and just we will launch the also mixture and select the Scarlett 18i8 device and look at the routing. Okay, we see that SPDIF1 is routed to analog 2. That's strange. We see that SPDIF output 1 is routed to analog 1. That's strange too. I have routed it to SPDIF. Analog output 8 is routed to analog 1. And there's nothing related to this. That's strange. I think I need to see what's happened. Oh, I believe the problem can be that the Focusrite software didn't save the config. That is very probably. I need to check again, connect to the Focusrite control the device and check. It seems that it isn't properly storing the state of the device. Yes, it didn't save the state of the device, so I need to restart the Focusrite control device, Focusrite control software, and relaunch it again and reconfigure the device. So let's do reconfiguration. I believe it is a bit buggy anyway, so I need to reassign the routing. And LX6, LX7, and LX8. Here we'll route SPDIF to SPDIF, and here SPDIF to SPDIF, and route loop back to 8.1 and 8.2. Okay, now it's pretty good. We will wait some time until it saves the device state. It's okay, it's pretty not. And we will disconnect the device, check again that the configuration has been applied. So let's reconnect it. Yes, the configuration has been applied, so we can disconnect now and connect to the virtual Linux machine. So we have connected now and can look at the dmask-w. I think it has already initialized. So we need to select the device. Yes. And now we see that the routing is applied in the following manners. So SPDIF output 2 is routed to SPDIF 2. That's correct. SPDIF output 1 is routed to SPDIF 1. That's correct too. Now we have the following routing for analog outputs. 1 is routed to 1, 2 is routed to 2, 3 is routed to 7. I need to recall. I believe that's correct since the Focusrite device doesn't have the the 1898 device doesn't have the direct number of the ports. Then the output 4 is routed to 8, then output 5 is routed to 3, and analog output 6 is routed to 4, and 7th is routed to 5th, and the 8th is routed to 6th. So it seems to look pretty correct. Anyway, we will check the match a bit later. I believe not in this stream, but at this moment we see that the routing is pretty correct. Restored from the device state. So also we need to check that the routing of loopback lines has been set correctly. This is the PCM10 and PCM11 and PCM12 outputs. So the only thing I don't see the routing for PCM. I need to look through the mixture and find it. Here's an analog and speed, and I don't see. I believe that's I need to display all controls, and there it will be. Or it is entirely missing, and we need to add this a bit later. But I see mixture input routing, so it's there. I just need to find the PCM. I believe it is at the beginning of the list. Okay, there's a question. Hello, Satko. Can I ask an off-topic question? Is there a chance Ardu's show last touched automation feature will be support also by the LSP plugin series? Thanks for your work. I use it a lot. I don't know exactly what do you mean under the show last touched automation. I'm not so familiar with automation in Ardour. I believe I don't recall that the LV2 standard allows something related to the automation. The LV2 standard of plugins work a bit in other manner. There are just input ports, and the DAW controls how these input ports change relatively to the time. I can't answer this question. I need more detailed information. Sorry. Oh, the order can display the last parameter that is touched in the plugin as an automation. And how it is related to the plugins. Do any plugins support this feature at this moment? If yes, please provide the reference, and I'll probably dig into these plugins and look how do they interact with the DAW. But I don't remember that LV2 standard allows to do this in the plugin. I believe this is the feature of the host, and the host does it as it wishes. So that's the question that I can't answer at this moment. Sorry. Okay, we're looking for the PCM output routing. Air Windows or Vitellium. Maybe I just need to watch the use case of this feature. Okay. So there's PD for routing, and I don't see the PC. Oh, yes, there is PCM output and inputs. So we need to check the 11 and 12. So the 11th has a date 1, and it also has a mute as we have introduced. And the PCM 12 is added to. The only thing I don't think that this feature will be, if it is the feature of the plugin, won't be implemented in 1.2.0 version. There is already the huge amount of changes that will be in 1.2.0 version of plugins. So this is at least 1.2.1. So if it is the feature of the LV2 plugin, which plugins should support. So return to our current job. We see that PCM 11 is routed properly and PCM 12 is routed properly. I don't like that PCM 11 and PCM 12 do not have an alias and braces that show that this is a loopback output. But it is at this moment, it's not so important. I think when looking up again into the driver and checking its features, we will do some polishing, and when we will do some polishing, then we will introduce this renaming and aliasing of port naming. So so we see now that the routing works properly. The current task for us is to see how does the Focusrite control work with the stereo outputs and how it converts the mono output to the stereo output and back. So to do this, I think I will do non-standard routing. I will assign the even indexed inputs to the outputs, so they won't match. And after that, we will grab the protocol exchange of how we change the mono routing, mono channels to stereo, and watch how it will look in the messaging between the device and the driver. So I'll disconnect the device at this moment from the Linux virtual machine and connect it back to the Windows machine. So as I have said, we have monitor output 1, and we will assign the even output number to the ODD output number of the monitor of the even input number to the ODD output number of the device. So we will set analog 2 and so on, analog 3, analog 4, analog 5, analog 6, analog 7, analog 8. Oh, it's too sloppy. And analog 1 as a round robin method. Okay. Now we need to start our USB pcap tool. I'll launch the command line tool. Oh, sorry. Yes. We'll change to the... Oh, I think I need to launch it in the privileged mode, so I need to find the CMD. I cannot send the Control Shift Enter from to the virtual machine, so I need to use the Run as Administrator pop-up menu, cd program files, cd USB pcap. Okay. Now we can launch the, now we can disconnect the device, launch the USB pcap, and grab the changes from the driver. Yes, USB pcap cmd exe. Select hub 1 pcap file, converting from mono to stereo. Scarlett, how did I name the files? Scarlett 898, yes, Scarlett 898. Mono to stereo dot pcap. Yes, quite good. And now we will launch the device. Connect the device. Yes. And as we see, we will change the monitor output 1 to stereo and so on. So let's do it. As we see, the routing has changed to analog 1, 2. You see, yes? Then stereo to analog 3 and 4. That's interesting. Then stereo analog 5 and 6. And other port assignment has changed. Is that correct? I think we need to check again. We need to reassign the ports again. Maybe the configuration was not applied to the device again. So I think we need to close the Focusrite control device, stop the USB pickup, delete the file. Yes, this file. Then launch the Focusrite control device, Focusrite control driver software. Then assign the analog outputs again. And one. Yes, that's good. Now we can close the software. Disconnect the device, connect it again, and see that we have correct routing. So let's connect. Let's relaunch the Focusrite control. And yes, we have the correct routing that we have already set. So now we can disconnect the device, launch the USB pickup, select one, and the file name is Scarlett 1898 mono to stereo pickup. Okay, and now we are ready to connect the device. We have proper routing, and now we will wait a bit and switch from mono to stereo again. So let's do it. Oh, what do we see? We see that the driver has reset the routing of analog outputs completely, entirely. 6, 7 will be reset to 5, 6, and 8 and 1 will be reset to 7 and 8. That's interesting. So we see that odd number of output always requires to match the odd input of port. So the pair always starts with the pair of ports always starts with an odd number. So we can select here only pair of 1 and 2 analog outputs, 3 and 4, 5 and 6, 7 and 8. So we will stop the capturing now. Or yes, we'll stop the capturing now and do the reverse job. We will convert stereo to mono. Oh, I forgot to convert SPDIF and loop back. So we'll do additional capturing of these settings by additional pickup file. So we'll disconnect the device. launch the USB pickup CMD exe, select the one and write the Scarlett 18i8 mono to stereo to dot pickup and complete our job. So here are our settings, and we will just switch to stereo and switch to stereo. Yes, that's pretty enough. Now we can leave USB pickup. And now we'll do the reverse job. We will just convert the stereo tracks to mono tracks. So for this case, we will do the following. We'll disconnect the device, launch the USB pickup again, and select the port, the hub 1, and write the file Scarlett 18i8 stereo to mono pickup, and launch it and connect the device and do the conversion. So now we just do we shut down the stereo button and look at how the stereo version of ports behave. So this, 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 and this. So it's pretty not, and we can stop the USB pickup, and we can disconnect the device. Yes, we can disconnect the device. And now we can copy the files to the Linux machine and look the protocol dump. Oh, what was happening? The Windows machine has hung up. Oh, it has rebooted. Wow. All right. I believe that were stable Focusrite drivers or stable Windows. I don't know. But that's good. That's interesting. Or maybe something else. Okay, I'll just enter the password. Where's my... Oh, yes, here it is. And Windows update. So your PC ran into the problem. Oh, don't send. Yeah, we don't need that. So we need to launch our file manager and take the files from the C program files USB pickup. Where is it? Oh, that's x86. And we need the program files without the x86. USB pickup. Here it is, and there are files mono to stereo, and stereo to mono. There it is. And we just copy it to the virtual network storage Focusrite here. So at this moment we'll walk here, and here are our files, and we will launch the decoding tool. So run sh. I will launch this from console. Run sh ff Scarlett 18i8 Oh, it has just rebooted. It has just rebooted suddenly. That's interesting. There was no blue screen of death. It just rebooted, and that's all. Yeah, that's interesting. Scarlett 898 and mono to stereo pickup. Okay, now we can open our Kate tool and open the file we have just generated. So there's Focusrite Scarlett backports, reverse engineering, and then we need to open the clean, I believe. Yes, clean file. We'll accept the restrictions and disable the line wrapping. So here's the driver initialization as usual. This will last about 10 seconds, and after that we need to find out the first data exchange, and I believe here it is. No, no, where's, oh, I think, yes, here it is, and I believe the first one is here. Yes. So let's look a bit upper. I think I need to detach this into a single window. I don't know how to do this at this moment. I don't want to spend much time for it. Anyway, there's just some exchange between the device and the driver, and this exchange, I believe, is related to the metering of the signal. But finally, we get the following message, which starts here. And as you remember, we have changed the routing of the monitor output 1, which has been set from mono to stereo, and affected the monitor output 2. And we see that there is a set data operation that changes the 2 bytes, or don't changes. Set data. The offset is 34 in hexadecimal, and I need to check again what's the data is accessed. So let's look. Here it is, pickup. Oh, no, not reverse range, and the config space. And 32 is software volume settings. Oh, I understand now what's happened. Let me explain, please. As you see in the driver of the Focusrite device, I'll just connect it and launch the Focusrite control. We see that we also have the gain settings for the output. And I believe when we have changed the analog mono monitor output 1 and mono monitor output 2 to stereo, the driver had to apply the same loudness to both channels, and that's why the loudness was set for these channels. And this set data operation is the setting of loudness. So we need to remember that changing loudness, that when the driver changes the mono to stereo, it also changes the loudness of the outputs. And I believe it copies it from the first output to the second. So this is the loudness for the first and for the second monitor output. Then we see that the byte with the offset F8 in hexadecimal has been changed to from 0 to from 02 to 01. This is exactly the routing of the monitor output 1. So we need to record this somewhere. So we'll create new file. Sorry. We'll create new file and write all the desired things. So monitor 1 to F8 F8 from 02 to 01, and before offset is set from 0 to 03. I believe this is the bit mask again, so we'll check that later. And 1BE was changed from 69 to 66. So we see the huge amount of changes from 69 to 66. What's more, 1C2 was changed from 67 to 66. Okay. And that's all. And as usual, we see that changed checksum of the configuration space, and we see the setmux call that changes the routing of the device. So that's pretty clear. Let's look further. Here, as usual, we see the setting of the loudness controls. I think I need to remember this too. So we will set 0x32 FDFF to FDFF and 36 from FDFF to FDFF. The value didn't change, but the device driver has set it. So after monitor outputs 1, 2, there are there is monitor output and monitor output. This is one, and this is second monitor output. And what we see then, we see 40 and 42 to FCFF. I need to recall again what's there. This is also the hardware volume settings. Yes. And we will look at this a bit later. I believe not in this stream. Anyway, what's next? The offset FA changed from 4 to 3. That's pretty correct. This is the routing settings. One before was changed from 3 to F. Yes, this looks like a bit mask. We have added additional 2 bits, bit number 4 and bit number 3, starting number with 0. And the one CA is this is the routing of the second channel, I believe. Or probably not. And C6 and CA. I think, yes, this is routing C6, 6, and adding 4, we will get the A. So that's right. And we just need to remember the values changed from 67 to 66 and from 68 to 66. Then what's next? And nothing more. Okay. This is how the routing works, the driver key. Then there are outputs NL 3. Oh, this monitor output. Yes, this is just monitor output. Yes, that's right. This is for this is monitor output. This is NL 3 and 4. Then the analog 5 and 6. Oh, headphones 1 and headphone 1 left and right. And headphone 2 left, right. And there will be headphone 2 left, right. And there will be SPDIF. And there will be a loopback. So let's see the headphone settings. That's a bit low here. We see that bytes 38 and 3A have changed to values 0, 0, and 0, 0. That's strange, but I believe there is the hardware control set for these inputs, probably, or not. Oh, the gain settings, I believe. What's the value? It doesn't show. Here it shows that -3 decibels, I believe. Or it doesn't show. Yes, there is -3. It doesn't show anywhere the value. Oh, here it is, the -1 decibel, -2, -3 decibels. And the 0 is, I believe, the 0 decibel. Yes. So here it is. -3 decibels. Okay. That's pretty. -4. Oh, it's too sloppy. 0 decibels. It's too. Now it will do the job for a long time, switching from one value to another value. Oh, that's how the software control work. Okay, we don't want to wait until it ends with the changes. So we see that the value was set at offset 38. So we'll record this here. Oh, well, I have already copied. I just need to write a proper value to 38 and 3a. And the value is from 00 to 00. That's pretty expectable. And the second two from 00 to 00. And the additional offsets of the software configuration area. So the offset F6. Oh, FC. From 6 to 5. And one before from F to 3F. That's pretty expectable. So we'll just take this copy, and from here was 03 and here was 0F and set to 3F. And then we will set the 1CE offset from 68 to 66. And 1D2 from 68 to 66. I don't know what's the 66. What does the 66 mean? I just need to check that. What the addresses are there. Okay, and what's next? And nothing more, I believe. Yes. This is the control sum and nothing more. Okay. I don't understand why it's saying all 266. I believe we'll find out it a bit later. Let's look to the headphone 2 settings. FE. Oh, there is the bytes that was changed. There are 3C and 3E. And the level is 0 decibels, so it's pretty. 3C and 3E. And then after that, the offset is FE. It was changed from 8 to 7. The one before, as expected, was changed from 3F to FF. The D6 was changed from 6A to 6.6. And 1DA was changed from 69 to 6.6. I don't know what's this. I believe this is the mixture settings. I need to check this. And we have the changes in the control sum and nothing more. Okay, now we have completed with this protocol dump. We need to decode the second protocol dump and look the changes there. So we need to launch the monitor stereo 2 pickup decoding. Kate should reload the file. Yes, reload the file. And now we're ready to look to the second protocol dump. So where are our first changes? Just need to scroll here. And I don't see any changes. And that's strange. Or probably I'm wrong somewhere. This is the initialization code. And somewhere here we should start the update. Oh, here are set data, and I believe a bit later or a bit earlier. Yes, here it is. So here we see that there is no changes to the hardware volumes, so since the SPDIF outputs don't have any hardware volume control. We just see that there are changes related to the offset X1B5. The mask was set from 0 to 03, and this is the second byte in the 1B4 word, which is a little Indian word, 4-byte word. And we just see that the offset 1B5 has been changed from 0 to 03, and this conforms to the bit mask and port assignments we have previously investigated in the device driver. And nothing more except the routing, I believe. Nothing more except the routing. Yes. And there is no routing too, since the port assignment didn't change. We had the SPDIF1 routed to SPDIF1 and SPDIF2 routed to SPDIF2, so we don't have any setmux message here. Let's look further and look at the last changes. And as we see, the B5 byte has changed from 03 to 0F, and that also conforms to what we see. So, now we can say what? We can say that the one before is a word that indicates that the ports are configured in the stereo mode or in mono mode. 1C6, I think I need to check again the notes that I have already written and check the offset. There's 1C6. There is spam. Okay, let's look. 1D6, 1D8, 1C6, 1CA, and what's this? Oh, ha. 1BC, 1B8. 1B8 is the logic mutes. No. 1C6. 1C6 is somewhere here. So here we have volume settings. Yes. We have this Focusrite control has volume settings remembered for each output. So when we have this slider, the Focusrite control doesn't write it to the device configuration area only. It also writes the volume settings to the internal configuration, and we will discover these volume settings, I believe, in the next or the next in the next stream, or one stream after the next stream. Anyway, this is just the volume settings stored of the output or updated. So we won't look at this now, and we just need to check that we just need to manipulate the one before 4-byte word to ensure that the routing that the loudness of that the channels are used in the stereo mode or in mono mode. I think we need to have a short pause for around 2 minutes, and I'll get back. All right, I'm back, and we are continuing. In the previous version, version of my driver, I didn't implement these controls. Instead of this, I have just added the device configuration to I have added the code that migrated the stereo device configuration to mono device configuration. But I think that implementing the current behavior by switching ports to the stereo mode is better. So I believe we will start writing the code from scratch today that will manipulate these bits and set the proper settings of the mixture. I think this will be interesting, and let's start doing this. So we already have the mixture Scarlett Gen 2 driver opened, and we'll find some switch that will look like we want to do. So this should be the on-off toggle, and I believe the best way to implement it is to copy from some other example from this driver and just adapt this to our desired behavior. So for that case, we need to connect the device to the Linux machine. Yes. and launch the Scarlett USB mixture and look, there are, yes, here it is, the phantom power settings. So we can look at the phantom power settings and see how they are implemented, and do in the same manner our implementation of mono to stereo switching. So let's look. So I believe we need to look for phantom word. This is too early. I believe I need to scroll. Also disable the line wrapping. And see, starting from here. Look starting from here. Update input data. That's not that I expect. Yes, phantom power switch controls. This is the exact what I was watching for. And this is the sound driver control element type phase mixture, the sound control boolean mono info, Scarlett 2 phantom control get, Scarlett 2 phantom control put. Okay, that seems that there is nothing special except that probably the output has a special naming. So we'll look at this a bit later, and let's now write the template code for function. So I believe we can do this something nearby, and then we can drag the code to the more proper place. So here we'll add the stereo output mode control. Or no, that's not correct. I can output stereo mode control. This is more correct. Then we need to describe the port. Nothing changes except that we rename the phantom to the stereo mode. And here we change the phantom to stereo mode. And additionally, we take the code of the functions, copy paste it, and rename. So we have stereo mode control get, stereo mode control put, and remove all unneeded code. So here we should write our code. Here we compare the old value with the value, and all is okay. Then we change it and update the code. Stereo mode control put, stereo mode control get. Now we are missing the stereo mode settings in our device settings, so we need to implement additional field. This should be somewhere nearby to the mute switch, and here we will add additional settings called stereo switch, and the number of outputs can be safely reduced to twice reduced. So there is stereo switch, and after that we need to write the proper value to the stereo switch. I need to add a bookmark to here and here. And when changing, we just need to write the value and do some stuff. So I'll copy the value. I'll copy the code and update. So I need the index. So here it is. And I need to assign the proper value to the proper index. So there is not phantom switch. That's the stereo switch, and the value control returned. So here is the index. So is something more required to do with this? At this moment, I believe not. But further, I believe this should be additionally or not. No, it shouldn't be additionally affected. So this is just mono to stereo switch, yes. So here is pretty simple, and that's key. Here, the stereo mode control put, we have the stereo switch value, and setting the stereo switch, we need to do several changes. First of all, we need to check the routing, and I believe truncate the routing. Anyway, the first thing that we should do to use not the phantom switch, but use the stereo switch. And if the stereo switch has changed, what we need to do, we need to set the bit mask in the software configuration area. So also we need to check that the software configuration area is present. So if we don't have any software configuration area, then we need to forcibly exit from the device, from the function, and probably return some error. Or not. I think we will return the EBIT state. EBIT state. I think we will return the inval. That's pretty not, and go to unlock. So here we'll write a comment that check that the software configuration area is present. Now we have the software configuration area present, and we can set the corresponding bits of the settings. So we just use the corresponding word to set the bits. So we need to 32-bit value, and we will assign this value from the software configuration area. I need to look at the description of the software configuration area. The structure, how the field is called there. Here it is, the stereo switch. And we need to convert the little Indian value to the CPU value first. So mask assign LE to CPU. I believe this is looking like this. Or without, oh, just without underscores. Okay. LED CPU and access the private software config stereo switch. And after that, we need to update the mask, set or unset the bits. So we will write an if statement, or maybe not the if statement. We can write just mask assign. If the value was changed to 1, then we set once. Oh no, I think we still need to write an if, since the changes from mono to stereo can be more heavier and affect the routing and so on. So we will write if well, if we set the stereo mode, else we unset the stereo mode. When we unset the stereo mode, the code is pretty clear and pretty easy. I think we just reset the corresponding bits of the mask, and that's all. So let's do this. Mask assign mask and not. I think this should be in this thing in the shortened form. This should be written in the shortened form. Mask applying bitwise and to the value 3 shifted by the index value, which is shifted by 1 or multiplied by 2. And inversed. And for safety, I will convert this to U32. So I'll just use this and write U32. So we shift the bitmask 3 by the number of the part, which is multiplied by 2. Inverse this and apply the mask value to it. And after that, we can call the update software config. commit software config. I won't write it from scratch. I will just copy the call, and this is pretty not. So I will just write this, write the Scarlett to commit software config. Uh, Pretty good, and just pass the address of the stereo switch field to be updated. So here I will write the same code, except that the mask will be set. So we will set the bits shifted by the index shifted by 2. And here we need to check that the error is positive or 0. And this is pretty enough. So now we have the control over the bits. Now we need to read these bits somewhere, add the corresponding controls, and then after that we need to initialize the value of stereo settings. So I think we need to look at the place where are the mutes created. Let's look. This is I believe this is as output control settings initialization. Add line out controls. And here's our mute creation. Port mapping. If port mapping is present, we creating mutes. We are creating mutes, and we also will create the stereo switches. So for I believe for even number of for odd number of I, we'll create additional switch. So here we are creating mute switch, and we will add additional switch for the stereo mode. We will write the comment first. For each ODD output. And here we will check if I and for each even output starting with 0. That's more correct. And we can check for even number with this instruction. And if this is the even number, we will just do our job for adding the values. So here's the Scarlett 2 format port name. I need to look at this again. Oh, there's an extra line break that we don't need. And there are Scarlett 2 ports, and there is a description. Yes. For source and destination. And I believe that requires additional fields for pair destination. but the pair destination is required only for outputs. So I just need to dst pair description field and initialize this dst pair description field. Or not pair or stereo, I think. And right here, analog output this. 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 And this. And I believe I need to add additional function that will format the pair of ports. The name of pair of ports. So there is format port name and format stereo port name. And here we will add the direction, port type, port number, and that's pretty enough to pass the correct values. Port num plus 1 and port num plus 2. And we should use I believe, just dst stereo description without any condition. And we don't need the direction as an argument at all. And that's why we should write the output stereo port name or stereo output port name. That's more correct. So we have the Scarlett ports, we have the formatted string, and now we can use this in our initialization code. So we will do this here, Scarlett to FMT stereo output port name as size of s. We don't pass the direction, we pass the port mapping type, port mapping hardware offset. And I believe I need to look how the phantom is used. Phantom power switch. Phantom power switch. Okay, phantom power switch. So this will just will be set as stereo switch. Stereo switch. Oh, okay, that's pretty enough. And here we need to add the value. Oh, index. Compute the index of the mute. Okay, we need to use not I, just index here, and use index as an index but shifted by 1 right, so divided by 2. Index shifted by 1. We have truncated the value. So, and after that, not private mute controls, we need to add one more array inside the Scarlett data, stereo switch controls. So here, stereo controls. Okay, that's good. So here we pass the stereo controls. I think I needed to implement additional variable stereo index and initialize this to not to confuse. With this value, and here use just stereo index. So Scarlett 2 add new control mixture, Scarlett 2 mute control, stereo index 1 as private stereo controls. And of course, this is not mute control, this is stereo mode control. Yes. So after adding this, we have the settings set. There we have the port controls added, but we don't have the settings initialized. So we need to initialize the settings. I need to look where the mute control is initialized. Here it is. And we need to add the initialization of this field. So we need to write private stereo switch, add the stereo index, and check that corresponding offset is set inside the bit mask. So we need to read this bit mask first. So we need to stereo mask. Read this stereo mask here. And use this stereo mask here. So we just need to check that at least one bit of 2 is set at the corresponding position. So we just need to shift 3 by the index and apply the bitwise AND and check that the value is not 0. So that's pretty enough, but not software mutes. Instead of this should be the stereo mask. And of course I will cast the 3 to U32. So I think I need to add logging here. Create mutes. Yes, and I believe there is login. Yes, here is the login. And here also the stereo switch should be locked. stereo switch, the stereo index, and the value set. Stereo switch, the string, this is the name of the port, and log the value, of course. And I think I need to add the login of the mute switch state to value 2. So the here, and write the private mute switch at the index. And then we need to check the error. And if all is okay, then we continue. So here's the stereo switch, stereo index, and we need to pass the value that we have read. Here it is. And probably that's all. So I think we are ready to launch the first implementation of the driver, check for the errors, and go further. So I need to go here and launch the build process. So I will launch the make J8 and look for errors. Okay, there are errors, and I believe the errors are related to that fact that I forgot to add commas. Yes. Here, 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 and here. Okay, let's relaunch the compilation and check again what's happening then. There's an error at line 3072. Let's go there. Software config stereo switch, of course. This is the pointer, and I need to access it to the field as to the field of the pointer to the structure. There is an semicolon missing somewhere. Oh, here, of course. And there was some compilation process in progress. We need to wait a bit. Format stereo output name. Stereo output port name is not used. That's strange, since we have added the reference to it. Yes. I believe this is the result of the previous errors. We're waiting. The first compilation is pretty long. Okay, we have relaunched the compilation, and there's still error. I believe I have forgotten one of the braces at line 38, 33. Let's check. And yes, we have missed one closing brace. And that's all. Aren't there extra braces? I think there are extra braces that aren't required. So here, here, and here. So yes, there was an extra brace that wasn't required, and we can relaunch the compilation process. Yes, the module is building, and now we're ready to relaunch. Reconnect the driver. Reconnect the device and relaunch the driver. So I have already disconnected the driver. We will skip some space. Here we will wait until the kernel driver gets ready, and we will copy this driver to the current tree of kernel models. Okay, the module is ready, and we are ready to do the RM mod. SND USB audio. Copy the sound USB, SND USB audio KO to the lib modules 5.15 kernel sound USB audio KO, and mod probe the module again. Okay, we have done. So now we are ready to connect the device and watch what's happening. So let's do this. Okay, let's look what's happening. Is mute switch 0, analog output 1, mute stereo switch 0, analog output 1, 2. I think from more pretty looking log, we will do this for odd values. So if index and 1, this will be more more proper, since we should do this for the pair of ports, and we don't and if we don't have the pair of ports, then we shouldn't do this. So 0 1 stereo switch 0 0 0 0 mute switch 0 mute switch 0 stereo switch 0 stereo switch 0. Okay. So as we see, we have stereo switches set to 0, and this is true, as we see in our driver. Now we can do the following thing. We can look at the mixture settings and find the controls. Line out volume control. This is not exactly what we are searching for. I believe this will be at the end of the list. Oh, here it is. Analog output 3 and 4 stereo. Analog output 5 and 6 stereo. Analog output 7 and 8 stereo. And phantom power resistance. I think I need to look at the phantom power resistance, how it is generated, and probably this will look a bit in another manner. Phantom power resistance capture switch way. Zero. Maybe output, maybe add output. I think I need to recompile the driver and check. The strange naming of outputs for also is pretty bad. So let's disconnect the device. Compile the driver. Reload it and check. Okay, let's reload the driver and check for changes. Okay, we have the more correct output of the lag. So we need to check the mixture settings. No, nothing except that. Nothing except that the name became longer. So I think we will keep this as mutes. So we see that the settings of the output is muted at this moment. So it conforms to the case that when the setting is the stereo mode is set to off. So we'll keep this and just remove the output stereo switch. Okay. Now what we can do, is to check that we have properly read the bit mask, and for this case we need to disconnect the device from the Linux virtual machine and connect it to the Windows virtual machine. And switch some ports to the stereo mode. For example, monitor outputs 1 and 2, headphones 1. I think we can switch all. Oh no, we will switch with some step. So here, and probably we'll switch stereo, SPD to stereo. That's pretty enough. And now we'll disconnect the device and connect it back to the Linux virtual machine. So we see our lag, and we see that we have improperly detected the value of the stereo output switches. And also we have the mute switch set. Playback mute switch. Was it muted? Anyway, this is the strange setting. We need to check the code again. So here is the stereo switch. Here is the index. Here is the stereo mask. Oh, yes. We consider that the index is even, and now it is odd, so we need to do the shift stereo index shifted by 1. That's more proper. What about mute switches? That's strange that we have mute switches set to ones. Oh, or not. I think I need to connect the device and check again for mutes. So I need to relaunch the compilation, disconnect the device, and connect to the Windows again. Is it really muted? No, it's not muted. Or do we have another mutes for this? I think we need to check. Okay, the driver has been recompiled. Let's reload this and connect back. So we don't have any mute switches enabled, so we need to disconnect the device and check the driver again. So here's our log. And what do we see again? So we see that in the output, the numbering is improper, yes. The numbering is improper since, yes, we need to do the proper numbering here. -1. Okay, so the analog output 1 to 2 are set to mute. The analog output from 4 to 5 are set to non-muted. The analog output from 6 to 7 are set to muted. And analog output from 7 to 8 are set to unmuted. Also, we have an SPDIF muted, but I don't see the SPDIF muted setting. So we have not properly detected the muting switches. I think we need to dump the state of the software mutes and stereo mask. Oh, software mutes have already been dumped. We need to set the stereo mask. That's good. And for mapping count, index for mapping software offset. Okay, it's pretty clear. I think I need to dump the mask used here. I don't think this is reliable to use additional comment. We'll dump just the mask. Or here, or even here. Bits 0x x 0xx. So here we'll just dump this. Just one more string and this way. Yes. So stereo switch. Okay, we have the mask, we have the stereo index, we have the settings set to stereo, and we just need to disconnect the device, compile the driver, and relaunch. And of course, we need to save the file. Oh, there's an error. I believe I have forgotten the comma. Yes. Now we install new driver and connect the device. Let's look. 3, C, that's right. 3, C, that's right. 3. And what's the stereo mask? 3, 3, 3. This should work, this should work, and this should work. But I don't see that. PCM was set to, that loopback was set to stereo. Something's wrong. Oh, stereo switch set to 1. SPD, yes. Yes, that's right. Okay, we see that SPD was set to 1, and that's proper setting. Yes, we have three pair of outputs set to stereo, and we see this quite good. We need to look at the driver, at the mixture settings, and look how it, and see how it looks in the UI. Okay, so what do we see here? The SPDIF output 1 to stereo is enabled. The SPDIF out, the analog output 7-8 is disabled. 5-6 is enabled. And one more analog output 1-2 is enabled too. Okay, that's good. The only thing I think there should be the port remapping applied if this is the analog output. So we need to check this. We need to check this again, but a bit later. At this moment, we have the mute switches, the stereo switches working. Now we need to probably to check the additional things that we should do when switching from mono to stereo. And that's why we need to go back to the function and watch the code. So first of all, we set the software config that the stereo mode is enabled. The second thing we should do is to set the routing, update the routing. So we need to check the number of ports set for corresponding output. We need to check the number of input set to the corresponding output. Probably truncate this number to to make this number ordered if we start numbering from 0. Make this number even if we start numbering from 0, and update the routing of both ports. And after that, we need to notify the mixer client about the changes of the routing and update the routing. and that's pretty not trivial. So we need to decode the port number, get the current port number decoded. So we need to get back to the structure, and we need also to get number of the port. So actually we need to get the number of the output number. So we need to have the int driver output number, and driver output number is the actual value shifted by 1. Is index shifted by 1, and we can use this. I don't want to use the driver output, just output number. Okay, we have the output number used. We don't need the braces here. So we have the output number. We need to convert to read the routing for this output number. So we need to source port number. So we need the input number, and we can read this input number. Check the routing settings. So we need to set the input number. To read the input number from the corresponding field of the data structure. So we have the mux. The private mux, and the access by the output number index. So now we have the input port number. We need to convert it to the 3 coordinates, the direction, the port type and port number. This can be done by the function we already have implemented. Mux num to driver port number. So we need to call this function. And if the call succeeds, we need to check the port numbers. So for this case, we will call we need to pass the port type, port number. So we need these variables int port type and port number. And of course, we need to pass pointers to them. Also, we need to pass the info. And pass the direction and mm, MUX port number. What's the MUX port number? Oh, oh, this is the enum that we need to convert. So that's right. So Scarlett port in, and the value is the output number. Oh, input number. And if the call succeeds, we do the stuff. So we need to truncate the least significant bit to 0. So that's just simple. Port num. I think we need to compute the new port number. And we need two input numbers. So input number 0 is the private MUX output number, and input number 1 private MUX output number plus 1. And here we use the input number 0, and new port number, we need also two values. Or no, we don't need it here. We need to new input number here. Here. So we update the part number to the corresponding value. We just remove the least significant bit. So just do the following thing. Yes, that's true. And after that, we compute the new input port number by applying the settings. So also, we need to consider that there can be no routing, and I think we can do this. New port number is assigned that as the port number, and binary end with all bits except the least significant, and this is for the first. And for the second, we need to consider that the port type is not none. Scarlett to port type none. And if it is true, then we just add the value to new port num. Add 1 to new port num. Otherwise, we just use the new port number. Yes. And now we are ready to check that the number of port has changed. Oh, we can translate the value back. So Scarlett to driver port number to MUX num. And assign the new input number values. Scarlett driver port number to MUX num. Set the direction to Scarlett 2 port in, port type to port type, port number to new port number 0, and info to private info. And the same settings we can do for the second port number. Pass the second value. So we see that we have changed the values, and now we need to ensure that they differ from the original values. So if new input number doesn't equal to input number 0, or new input number 1 doesn't equal to input number 1, then we need to implement additional logic. We need to update the routing. So we need to write the MUX settings, the new MUX settings. New input number 0 and +1, 1. And of course, I will just add the index here. And of course, we need to call the Scarlett to update MUX. Set MUX. So if the error is here, we need to go to unlock. And here we need to call the Scarlett to USB set MUX. And if the error is present, then we go to unlock. Otherwise, if all seems to be okay, then we need to notify the client software about changes related to MUX settings and all. So at this moment, a bit later, we need to do the same thing with volume control. So Scarlett 2 USB set MUX. Let's look here how the notify override bit and possible value change. Sound control notify. Okay, let's do this. We need to notify the mixer about the changes of the output port of the control port, and we need to pass the value. Card mask and the control identifier that has been changed. So we need to MUX controls to pass the MUX controls. Write MUX controls and pass the output number. And the second output number. So here we write a comment. Oh, I believe I need to use the C style comment instead of C++1. So yeah, here we write for migrating from mono to stereo, we need to do couple of changes. One, we need to set the routing of output ports of two output ports. Set the routing of two output ports. How to tell it in the right way? Set the routing of two output ports that are grouped into the stereo pair. The routing the input port should match to output ports. ODD numbers should match. ODD inputs should match ODD outputs, and vice versa. For stereo mono switch, there are no extra things to do except resetting the stereo mask. So here we need to check the routing settings and update routing if they have been changed. And here we need to write comment that we notify the mixer software about the changes, about the routing changes. And of course we need to call the setmux. Setmux, right? Yes. Oh, no, not that, not that. Scarlett to USB setmux, yes. Scarlett to USB setmux. So we need to write the comment here. The routing have changed. We need to update the routing and notify the client software. And of course, we need to log of all changes here. So we need to write the log message. So is there? So here, here we need to write that. First of all, we need to write the output number to the log. Of course, we need to write the call register the call. Scarlett 2 still remote control put. Probably here. Log the old value and new value. Of course, we need to write the output number. I think this can be moved from here to this place. And also the output number can be written here. So output number and then we need to oh okay, yes, we have updated the mask here. So we need to write we need to log the value here. So we can log the mask here, of course. So we can write the mask value here. And log the changed mask here. Okay, that's pretty good. Also, we need to write the input numbers. And compute the new input numbers. Right, log the new input number values. And if all has changed, then we do the job. Okay. I think we need to check how this how does this compile and probably probe the driver. I think there are a set of errors. Not so many. So 3099. Okay. So what's wrong here? Oh, yeah, yes. I was required to put the colon instead of comma. Card. Great. What's the card? Where's the card? Oh, I probably need to check how it's used somewhere else. Oh, yes. So let's put this here and check again the compilation. It looks like pretty well compiling. I didn't make huge amount of mistakes. All right, it has compiled. I need to disconnect the device. I think we will prepare the device for the test case. We will connect the device and do I think the unusual routing will disable the stereo mode for all outputs, and we will set the SPDIF output reversed. So we will set to SPDIF2, and here we will set to SPDIF1. So after the updated settings, we should notice that the SPDIF outputs should be swapped. Oh, we need also to update the routing settings. So we need also to update the software settings for routing. That's the point. So we need to look at the routing control settings. Mux source and enum control put. So we need to set also the software config. And we need to write the proper values to the software config. Probably. Or not. What was in our file? Yes, F8. The F8 is the routing settings, and yes, the routing settings have been updated too. And we need to update them in our code. So we need to add the encoding of the software port numbers here, and update the routing. So I think I need to set a mux USB set mux call. This is mute control. Here, mux source control can put. Is that right? Oh, that was my old version of driver, and here's the new version of driver, of course. And here we see that there's some settings, and I think this should be moved into a dedicated function. We need just to update the update the routing properly, and this should be moved into the dedicated function. So I will do this at this moment. So I commit software routing set mux. I just need to scarlett to mux source enum cdl put scarlett to mux commit output and pass the desired values. What do I need? I need the mixture and this is of course the do I need the mixture? Where is it used? Yes, I think I need the mixture struct USB mixture interface, and I need the output number and the input number. Scarlett to mute commit connection commit root that will be more sounding more reliable. So we have the mixture, we have the output number, and we have the input number, and we have the following function. Private is the part of the mixture private data, so we will do this. Where's the port count used? Do we actually need the oh yes, we need the line out remap. Okay, that's okay. So what do we need? We need to private mux output number input number. If private software config is present, then we do and return error, and we need to the error assigned to 0. We will move this to the top. And this short refactoring. And we will call the scarlett to USB set mux. And also we will check here that the value has changed. And if it hasn't changed, then we will just leave the function without any error. So if this equals to this, then we just leave. Check that the settings, the routing have changed. Good. Here we do the private views. The only bad thing is that we will call this set mux twice. So I think we need to pass the value to call the Scarlett to USB set mux. Or not. I think this shouldn't be called at all. This should be called by the color code. So we just update the mux settings and we update the software config. Yes, that's pretty good. And here we just commit the mux settings. So here we need just to if the old value differs from the current value, then we do the following. We just call the Scarlett mux commit root. So here we assign error pass mixture, pass the index and the value, and if error is greater than 0, then we call the set mux, and that's all. So we need to remove this code at all, completely remove this code. Okay, and I think this function should be moved at the top. To the place where the USB set mux message is sent. And here we can now commit the mux output number plus 0 and new input number. And if r less than 0, go to unlock. And the same thing, and do the same thing with the second output. And this can be skipped. And after that, we call the set mux. And then we notify the client software about the changes. So let's compile this stuff. There's a problem. 2213. Okay, 2213. Info. Oh, what's the info? Where they get the info? Oh, private info. Yes. Okay, that's not a problem. And index 2219. So here's the index, and I think I need to pass not the index but the output number. Yes. Okay, now let's check. Val is not 2214. Okay, that's not val, that's the input number. Okay, there's an analog 1, analog 2 setting, analog 3, 4, 5, 6, 7, 8, SPD div to 1. I believe I need to set the analog 3 to analog 4 and analog 4 to analog 3 routing. Hey, driver. Yes. Now I need to check that the configuration has been applied. I just need to restart the Focusrite control. Analog 1, 2, 4, 3. That's right. 6, 7, 8, 2, 8, 2, 1, 1, 2. And just reconnect and connect the device again to ensure that software has properly set the values. As you remember, that's not working always. 1, 2, 3. Oh yes, that it didn't change. So the driver is pretty laggy and pretty buggy. Oh, that's not playback. We need to work with analog outputs now. 5, 6, 7, 8, 1, 2. That's not right. 2, 1. And then 8, 1 and 2. So now let's disconnect the device and check again. One, two, four, three, and what's it with SPD? No, right, key. Now we have the properly configured the device for our test keys. We have the driver recompiled. Now we have the driver updated, and we're ready to start our experiments. So now we're disconnecting the device and connecting to the Linux machine and watching the output of the driver. So all stereo switches are turned off at this moment. The routing is set. Okay. And now we can connect the device from mixture software and change SPD from mono to stereo. Bam. Wow. And the problem is that we probably haven't committed the new value of the flag. I need to check. Still get, control get, and control put. Ah, we forgot to commit the private stereo switch index value. So let's do this here. And probably we need to do this at the end of the driver. Okay. Update the stereo flag. So anyway, we have routing updated and we have the software configuration updated. Here we see the common software config call and common software config call. So we have updated the routing of two outputs. And I think we need to disconnect the device and connect again and check the routing of SPDIF outputs. And also recompile the driver and redeploy it. So now we should see that the stereo setting is enabled for the output and the routing setting is enabled too. We have redeployed the driver and let's check. We see that SPDIF output isn't set to stereo. That's strange. The mask should be updated. Let's check the log again. And before this, we need to check the routing. Where's the routing of the SPDIF? Yes, SPDIF output is routed to SPDIF2 and SPDIF output 1 is routed to SPDIF1. That's correct. And the only problem is that we don't see the SPDIF output stereo mode set on. So let's do the trick again and look at the log. Now it has been set. We have set the mask and committed the software config, but we haven't stored the mask in the software configuration area. So we need to update the value private software config stereo switch to CPU to a little Indian 32 mask. So now it will work properly. So update stereo mask. And I think this should be done here, since this is a common code for this and this part. And yes, here. And this code should be removed. Yes. So we are ready to recompile the driver again and check that now it will properly set the value. At this moment, it didn't commit the value of stereo output. Okay, let's launch the driver. We see that the mute switch is not set, and that's right since the driver didn't commit it. And now we will update. We will set the stereo mode, and we will see that the software configuration has been committed. And that's good. And now we can disconnect the device, connect it again, and check that the mask has been properly set. And connecting the device. And we see that the SPDIF output 1 to 2 stereo switch was set to 1. And we should see this in the mixture settings. Yes. Now let's try to do the same thing with the analog outputs. So let's look. Analog output 1 to 2, we will switch into stereo mode. And here we will log the changes. Okay, nothing has changed since analog outputs 1 and 2 have the direct routing to the corresponding odd and even numbered ports. What's the routing? I think we can try to switch 3 and 4 to the stereo mode. And there was a mux update. That's good. And I think we can connect back to Windows and check that our settings have been deployed to the device. So let's disconnect the device from here and connect it here. Let's look what the Focusrite control will see. Let's try again. Yes. Oh, we see that analog 1 and 2 stereo have been set to stereo. Analog 3 and 4 also have been set to stereo, and SPDIF has been set to stereo. That's good. The undone thing is that we allow to set the routing to the SPDIF1 to be the ordered or even number port. So I think we need to to write another one code related to changing the number of input when routing when sending when configuring output routing. We need to consider the mode of the output, and if it is set to stereo, we need to allow only corresponding inputs. But I think I need to check this code. Mux control put. How is it called? SCAR to USB sec mux, and where's called, and mute control put, stereo mode put, which we have written, and mux source enum control put. Yes. So here, what do we see here? We see that there is an old value and there is a new value, and the problem is that the value should be set with some step. I think I will keep this for the homework for me, and I won't do this in this stream. I will just show the result in the next stream, and at this moment we will stop, since there are already 3 hours gone, and the only thing I just need to do is to commit the changes to GitHub. So let's do this. I'll quit from the also mixture, copy the changes to the GitHub repository and commit them. So let's review the changes. Git diff. Yes, we have added the description for ports. We have added additional stereo switches. We have removed the extra line ending. We have added the formatting function for stereo port pair. We have added the function that commits the root. I think it is a good reason to add the check here. Yes, it is a good reason to do this here. Or maybe in control put. I think control put is enough. So we have added the function that allow to change between stereo and mono modes. And we notify the driver about the changes of the routing. Also, we can check this by doing the following thing. We can set the SPDIF2 and SPDIF1. Oh, still, what? SPDIF1? I believe it has already lost the device. I need to reconnect and check. Yes, it didn't come in the changes to the device, so I need to reconnect the device and restart the Focusrite control. I'll explain the case. There's SPDIF1 to 2 stereo switch, and there are routing settings. If we look at the ALS mixture settings, when switching from mono to stereo, we should see in the ALS mixture the change of the routing between the SPDIF1 and SPDIF2 outputs. This one thing should be checked more, additionally checked. Okay, and Focusrite control, and we will set the SPDIF settings. I found that when it's working too slowly, then it has already lost the connection with the device or something else, and doesn't commit the changes to the device. So now it's pretty good. Let's reconnect it. Connect it again and check. Yes, good. SPDIF2 and SPDIF1. All right. Now we need to just to disconnect the device, connect to the Linux machine, and run the ALS mixture. Switch to Scarlett, switch to all, F5. Roll to the end, scroll to the end, since SPDIF outputs are there. And we need to check the reaction of the routing. So we will switch, and these values SPDIF2 and SPDIF1 should change, should be reversed. And that's what we have expected. That's good. All right, now we are ready to commit. F10 and git diff. And let's review our changes a bit more. We have added the control. We have added this stereo switch buttons, and we have removed the code that will be reused by two functions. So that's good. We can now write a git commit with message implemented as mono to stereo switching for Scarlett ports. Oh, git add, right? There's no changes. Then we have committed and now we push the changes. So I think that's the end of our stream today. And we can, sorry, I need to ban the spam bot. And I think we can end up with this today. We did a good job. We finally found out how the switching from mono to stereo is performed. The only problem is that this is non-simple, non-trivial function, and this affects not only the routing, it also affects the loudness. And we are not completely done with the routing and volume settings. So we will continue working on volume and settings, and when it will be done, then we will be happy. Thanks for watching. Uh, the next day I will perform an additional audio stream, a video stream, but this video stream will be related to the audio production. So please don't skip this. Thumb ups, subscribe, donate the driver development. Every donation helps me to get get closer to purchase the new Scarlett device, which I can use for testing the driver. So that's it. Bye bye. See you soon.